Now moving on to 11th sum. An aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. Find how far apart will be the two planes after 1.5 hours. Now moving on to the solution. Let us note down the directions, that is north, south, west, east. He says that first aeroplane has flight due north. So from common point O, let us assume that aeroplane A has flight to certain distance in 1.5 hours with a speed of 1000 km per hour. Now he again says that another aeroplane leaves the same airport, that is point O, and flies due west at a speed of 12 km per hour. So after 1.5 hour, let us assume that aeroplane, that is second aeroplane, is at B. Now he asked what is the distance between first and second aeroplane, that is AB. We know that north direction is perpendicular to west direction, we can say OA is perpendicular to OB. So now moving on to solution. Speed of first aeroplane 1000 km per hour. So now distance travelled by first aeroplane in 1.5 hour will be OA, that is equal to 1000 into 1.5 hour is nothing but 3/2, which is equal to 2 goes in 1500 times, and 500 times 3 is 1500 kilometers. So we got OA as 1500 kilometers. Now similarly, the speed of second aeroplane is 1200 km per hour, and let us calculate the distance travelled by second aeroplane in 1.5 hour, which is equal to 3/2 times 1200 km per hour, that will be equal to 2 goes in 1200 600 times, we get 1800 kilometers. So we got OB is equal to 1800 kilometers. From Pythagoras theorem, we can say that in right angle triangle, hypotenuse square is equal to sum of squares of other two sides. Here AB square will be equal to OA square plus OB square, which implies AB square is equal to OA, which is nothing but 1500 square plus OB, nothing but 1800 square, that is equal to 1500 square is nothing but 22,500. 1500 square is nothing but 22,50,000 plus 1800 square is nothing but 32,40,000. So overall we get 54,90,000. Now finding the value of AB, we get root of 549 into 100. So that is nothing but 100 root 549. On further simplification we get 100 into, if we take 9 common here, 9 into 61, that is equal to 300 root 61. Therefore, the distance between aeroplanes after 1.5 hours will be 300 root 61 meters. Moving on to the 12th question. Two poles of heights 6 meters and 11 meters stand on a plain ground. If distance between the feet of poles is 12 meters, find the distance between their tops. Now moving on to the solution. He has given that two poles of height 6 meters and 11 meters, which are 12 meters distance apart, lie on the ground, and he asked us to find the distance between tops. Let us assume that AB be the first pole and CD be the second pole and BD be the distance between the poles. Then he asked us to find the value of AC, that is distance between the tops. In order to find this, let us draw a line joining A to CD, that is AE, such that AEBD forms a rectangle. AB is equal to 6 meters, CD is equal to 11 meters. Then we get CE or EC is equal to CD minus ED, which is equal to CD minus ED is nothing but AB, as it is a rectangle, that is equal to CD is nothing but 11 meters minus AB is nothing but 6 meters. So finally we get CE is equal to 5 meters, and also we get AE is equal to BD, as in rectangle the lengths will be equal, which is nothing but 12 meters. So here we also got AE. We know that AEC is a right angle triangle. Therefore, by applying the Pythagoras theorem in right triangle AEC, we get the hypotenuse square, which is nothing but AC square, is equal to sum of square of other two sides, that is AE square plus EC square. That implies AC square we need to find, which is equal to AE square, that is 12 square, plus EC square or CE square is same, so that is 5 square. That implies AC square is equal to 12 square is 144 plus 5 square is 25. That implies AC square is equal to 144 plus 25 is 169. That implies AC is equal to square root of 169, that is 13. Therefore, distance between the tops of poles here is 13 meters. Moving on to question number 13. D and E are points on sides CA and CB respectively of triangle ABC, right angle at C. Prove that AE square plus BD square is equal to AB square plus DE square. Now moving on to the solution. Let us consider a right angle triangle ABC, which is right angle at C. Here he says that D is a point on CA and E is a point on CB. And finally he asked us to prove that AE square plus BD square is equal to AB square plus DE square. Now in order to do this, let us join AE, then we get triangle ACE as right angle triangle. Now in right angle triangle we know that hypotenuse square is equal to sum of square of other two sides. We can write AE square is equal to AC square plus CE square. Let it be as equation number 1. Now again let us join BD. Then we get triangle DCB as right angle triangle, and here hypotenuse square, that is BD square, is equal to BC square plus CD square. Let it be as equation number 2. Now let us join DE. Then triangle CED will be also right angle triangle. In this also let us apply the Pythagoras theorem. Then we get hypotenuse square, that is DE square, is equal to CE square plus CD square. Let it be as equation number 3. Now let us add both the equations 1 and 2. Then we get AE square plus BD square is equal to AC square plus CE square plus BC square plus CD square, which is equal to AC square plus BC square. Let us write it together, plus CE square and CD square. Let us write it together. Now if we consider triangle ACB, it is also a right angle triangle. Therefore by applying the Pythagoras theorem we get AC square plus BC square is equal to hypotenuse square, that is AB square, which is equal to, we know that AC square plus BC square is equal to AB square plus CE square plus CD square is equal to DE square from equation number 3. Finally we can say that AE square plus BD square is equal to AB square plus DE square. This is what the proof required for us. Moving on to the 14th question. The perpendicular from A on side BC of a triangle ABC intersects BC at D such that DB is equal to 3 times CD. Prove that 2 times AB square is equal to 2AC square plus BC square. Now moving on to the solution. He has given that AD is perpendicular to BC and DB is equal to 3 times CD. We know that here base BC is consisting of CD and BD. We can say BC is equal to CD plus DB, which implies BC is equal to CD plus DB can be written as 3CD, which implies BC is equal to 4 times CD, that is nothing but CD is equal to 1/4 times BC. Let it be as equation number 1. And as CD is equal to 1/4 times of BC, we get DB is equal to 3/4 times BC, which is, let it be as second equation. Now in triangle ACD, let us apply the Pythagoras theorem as angle ADC is equal to 90 degrees. That is hypotenuse square is equal to sum of square of other two sides, that is CD square plus AD square. Also, if we consider in triangle ADB, it is also a right angle triangle as ADB is equal to 90 degrees. Square of hypotenuse, that is AB square, is equal to sum of square of other two sides, that is DB square plus AD square. So here we need to eliminate AD square. So let us subtract both the equations, then we get AC square minus AB square is equal to AD square will be cancelled and we are left out with CD square minus DB square. This is in the form of A square minus B square, which can be written as A plus B into A minus B. That implies CD plus DB is nothing but BC into CD minus DB is nothing but 3 times CD. Then we get minus 2 times BC into CD. So now, in order to change the sign of right hand side, let us multiply it with minus. Then we get the equation as AB square minus AC square is equal to 2 times BC, and we can write that CD is equal to 1/4 times BC from equation 1. So finally we got that AB square minus AC square is equal to BC square by 2. Now by cross multiplication we get 2 times AB square minus 2 times AC square is equal to BC square, which implies 2 times AB square is equal to BC square plus 2 times AC square. This is what the required proof for us. Moving on to the 15th question. In equilateral triangle ABC, D is a point on BC such that BD is equal to 1/3 of BC. Prove that 9 times AD square is equal to 7AB square. Now moving on to solution. Let us consider an equilateral triangle ABC in which BD is equal to 1/3 of BC. So let us join AD here. As it is a equilateral triangle, we can say that AB is equal to BC is equal to CA. So in order to prove the required proof that 9AD square is equal to 7AB square, let us draw AP perpendicular to BC. Now let us consider in triangle APD, which is a right angle triangle. By applying the Pythagoras theorem, we get hypotenuse square, that is AD square, is equal to AP square plus PD square. Now again in triangle ABP, by applying Pythagoras theorem, hypotenuse square, that is AB square, is equal to sum of square of other two sides, that is AP square plus BP square. Now let us subtract both the equations in order to eliminate AP square. Then we get AD square minus AB square is equal to PD square minus BP square, which implies, let us make subject as AB square, then we get AD square plus BP square minus PD square. Now let us consider the two triangles, that is triangle APB and triangle APC. In these two triangles, angle B is equal to angle C and angle APB is equal to angle APC. Therefore, by AA similarity, we can say triangle APB, triangle APC. So, we know that when two triangles are similar, then their corresponding sides will be in proportion. Here, AP by AP will be equal to PB by PC will be equal to AB by AC, which implies AP by AP is nothing but 1 and AB by AC is nothing but also 1, because in equilateral triangle all the sides are equal. So we can say that PB will be equal to PC, that will be equal to half times PB, that is equal to half times BC. So this is in order to prove that PB is equal to half times BC, that is equal to AD square, let it remain as it is, and BP, as AP is an altitude, we can say that it bisects BC perpendicularly. So half BC whole square is nothing but BP square minus PD square. Then the equation becomes AB square is equal to AD square minus PD square plus BC square by 4, which implies AB square is equal to AD square minus, here we can write PD as BP minus BD whole square. Here we are also left out with BC square by 4, which implies AB square is equal to AD square plus, let us write the BC square by 4 here, plus minus BP minus BD whole square, which implies AB square is equal to AD square, let it remain as it is, plus BC square by 4 minus, let us expand in the form of A minus B whole square, that is A square plus B square, and here minus into plus is minus again, BD square plus minus into minus of 2AB, that is plus 2 into BP into BD, that is equal to AD square plus BC square by 4. We know that BP square is half of BC, so that will be again half of BC whole square, which is nothing but BC square by 4 minus, we know that BD is equal to 1 by 3 times BC. Let us replace it, 1 by 3 times BC square plus 2 times BP is nothing but half BC and BD is nothing but 1/3 of BC, which is equal to AD square plus BC square, and minus BC square by 4 will be cancelled. And now let us write this term here, then we get BC square by 3, as here 2 and 2 common in numerator and denominator will be cancelled, minus here 1 by 3 BC square is nothing but BC square by 9. That implies AB square is equal to AD square plus BC square by 3 minus BC square by 9 is nothing but, let us take 9 LCM here, then we get 2 BC square by 9, That implies, let us cross multiply with 9, then we get 9ab square is equal to 9ad square plus 2bc square. That implies 9 of ab square minus 2 times bc square is equal to 9ad square. That implies 9ad square is equal to 9ab square minus 2bc square. In equilateral triangle we know that BC is equal to AB. 9AB square minus, we can write BC as AB, then we get 2AB square. Finally we get 9AD square is equal to 9AB square minus 2AB square is nothing but 7AB square. This is what the required proof for us. Moving on to the 16th sum. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. Now moving on to solution. Let us assume an equilateral triangle ABC and let it have an altitude AP perpendicular to BC. We are required to prove that 3 times the square of side, that is 3 times AB square, is equal to 4 times the square of one of its altitudes. In order to prove this, let us consider triangle APB and triangle APC. In these two triangles, angle APB is equal to angle APC and also angle B is equal to angle C. Therefore, by AA similarity, we can say that triangle APB is similar to triangle APC. We know that when two triangles are similar, their corresponding sides will be in proportion. So here AP by AP will be equal to PB by PC is equal to AB by AC. We know that AP by AP is 1, so we can say PB by PC equal to 1, which implies PB is equal to PC. As PB is equal to PC, that will be half times BC. In equilateral triangle, as all sides are equal, we can say BC is nothing but AB. So here we got that PB is equal to PC is equal to half times AB. Now if we consider in right angle triangle APB, angle APB is equal to 90 degrees. So here by applying the Pythagoras theorem we get hypotenuse square, that is AB square, is equal to sum of square of other two sides, that is AP square plus BP square. That implies AB square, let it remain as it is, which is equal to AP square plus we got BP or PB as AB by 2. So let us replace it, AB by 2 whole square. That implies AB square is equal to AP square plus AB by 2 whole square is nothing but AB square by 4. Now let us transpose right hand term, that is AB square by 4 to left hand side, we get AB square minus AB square by 4 is equal to AP square. That implies, let us take LCM as 4, then we get 3 times AB square by 4 is equal to AP square. That implies 3 times AB square is equal to 4 times AP square, which is a required proof for us.